C. The development of the steam engine and mechanization. The steam engine and the process of mechanization represent two of the most transformative innovations in human history, playing a central role in the Industrial Revolution. These developments revolutionized production, transportation, and social structures, laying the foundation for modern industrialized society. From early conceptual designs to practical machines that powered entire industries, the steam engine and mechanization altered the relationship between humans, labor, and nature. 1. Origins of steam power. 1.1. Ancient and early concepts. Although the industrial use of steam would not emerge until the 18th century, the basic principles were understood much earlier. The Greek engineer Hero of Alexandria 1st century CE developed the Eolipile, a primitive steam turbine, which demonstrated the power of steam to create motion. However, this was used primarily for demonstration and had no practical application in industry. 1.2. Early modern ideas. Interest in atmospheric pressure and steam's properties resurfaced during the scientific revolution. In the 17th century, inventors began exploring how to use steam to create motion or lift water. Significant figures include Denis Papin, France, developed a steam digester and pressure release valve in the 1670s. Thomas Savery, England, patented a steam-powered pump in 1698, designed to remove water from mines. Though revolutionary, it had limited capacity and safety concerns. 2. The steam engine invention and improvement. 2.1. Thomas Newcomen, 17-12. The first practical steam engine was built by Thomas Newcomen. It was designed to pump water out of coal mines, solving a critical problem for the British mining industry. Newcomen engine used atmospheric pressure to push a piston downward. After steam condensation created a vacuum. Limitations. It was large, inefficient, and consumed a significant amount of coal. 2. Tundu. James Watt, 1765-18. The true breakthrough came with James Watt, a Scottish engineer and inventor who dramatically improved the steam engine's efficiency. Separate condenser. Watt's most significant innovation was separating the condenser from the main cylinder, reducing energy loss. Rotary motion. Watt later added mechanisms e.g. the flywheel and sun and planet gear to convert reciprocal motion into rotary motion, enabling the engine to power machinery, not just pumps. Partnership with Matthew Boulton helped commercialize Watt's engine, spreading its use in manufacturing, transportation, and agriculture. 3. Mechanization of industry. The application of steam engines facilitated mechanization, the process of replacing manual labor with machinery. This transformed traditional craft production into factory-based systems. 3.1. Textile industry. The textile industry was the first to undergo full-scale mechanization. Spinning jenny, 1764, by James Hargreaves, allowed one worker to spin multiple threads. Water frame, 1769, by Richard Arkwright, used water power to automate spinning. Spinning mule, 1779, by Samuel Crompton, combined features of the jenny and water frame. Power loom, 1785, by Edmund Cartwright, mechanized weaving, further centralizing production. Once steam engines replaced water power in factories, the textile industry no longer needed to be located near rivers, enabling urban industrial centers to emerge. 3.2. Iron and coal industries. Mechanization also transformed the iron and coal industries, which were vital for building machines and engines. Steam-powered blast furnaces increased iron production. Coal mining expanded rapidly, powered by steam engines that pumped water from deeper shafts. 4. Steam power in transportation. The steam engine revolutionized not only industry but also transportation, connecting markets, people, and resources more effectively than ever before. 4.1. Railways. George Stephenson built the first practical steam locomotive in 1814. In 1825, he launched the Stockton and Darlington Railway, followed by the Liverpool and Manchester Railway in 1830. Railways allowed for fast, reliable and cheap transport of goods and people, stimulating trade and migration. 4.2. Steamships. Steam power also revolutionized maritime transport. Robert Fulton's Clermont, 1807, was one of the first commercially successful steamboats. Steamships reduced travel time and increased reliability in river and transatlantic transport, opening up new trade routes and global markets. 5. Economic and social impacts. 5.1. Industrial growth. The steam engine allowed for mass production and more efficient use of labor. Factories could now be located anywhere, not just near water sources. Productivity soared, especially in textiles, metallurgy, and mining. 5.2. Urbanization. Mechanization led to the rise of industrial cities e.g. Manchester, Birmingham, Pittsburgh. Workers migrated from rural areas to cities in search of factory jobs. Urban overcrowding and poor living conditions became major social issues. 5.3. Labor and work culture. Steam-powered factories introduced shift work, standard hours, and wage labor. Artisans and home-based workers lost jobs, leading to resistance like the Luddite movement. Child and female labor increased, raising ethical and social concerns. 5.4. Capitalism and investment. Steam engines and mechanized factories required large investments, leading to the rise of industrial capitalism. Banks, joint stock companies, and stock markets flourished to support industrial expansion. Britain's industrial success fueled imperialism and global economic dominance. 6. Environmental and global consequences. 6.1. Environmental impact. Coal-powered steam engines led to significant air and water pollution. Deforestation increased to support expanding infrastructure. The environmental degradation of the early industrial age laid the groundwork for modern environmental crises. 6.2. Global diffusion. Steam technology spread rapidly to Europe, North America, and eventually Asia. Countries like Germany, France, and the United States adopted steam power to industrialize. Colonies were transformed into sources of raw materials and markets for industrial goods. 7. Long-term significance. The steam engine and mechanization laid the groundwork for the Second Industrial Revolution and modern industrial society. 7.1. Technological legacy. Paved the way for new forms of energy, e.g. electricity, internal combustion. Inspired later innovations in automation and robotics. Created the template for the modern factory system. 7.2. Societal transformation. Shifted economies from agrarian to industrial, created a new urban working class, and restructured social hierarchies. Prompted the growth of labor unions and political movements, advocating for workers' rights. 7.3. Global industrial order. Britain became the world's leading industrial power. Uneven global development emerged, with industrialized countries dominating world trade. The steam engine was central to the formation of a global industrial economy. Conclusion. The development of the steam engine and mechanization was a pivotal chapter in world history. It revolutionized how people worked, lived, and interacted with the environment. It enabled the massive expansion of industry, transportation, and urban life, fueling not only economic growth but also social upheaval and global change. From the clanking of factory looms to the roar of locomotives, steam power propelled humanity into a new age of progress and paradox, one marked by unprecedented innovation and equally significant challenges.